Alright, in today's video what we're going to be talking about is how our weight compares between the Earth and the Moon. So weight comparison. Okay, weight comparison between Earth. I'm going to do this in, let's do it in blue. Maybe green. Earth. Okay, and then we're going to do versus, and then we're going to put the Moon in white for obvious reasons. So Earth versus Moon. Now, how do we calculate weight? Well, we talked about this before, but there's a short form to doing it. Basically, the force of gravity is another name for weight. Force of gravity equals the mass, your mass, so this is U, the mass of U, times something called the gravitational field constant. Okay, so this is the gravitational field constant. Gravitational field. Okay, this is the gravitational field strength or constant. It's not really a constant, it depends on altitude and a number of things, but let's go with it. So the gravitational field constant on the Earth, so on Earth. What this tells you is how strong the Earth's gravitational field is due to its mass. Okay. Now, likewise, we have a gravitational field strength on the Moon. Okay. Notice something important though. The mass doesn't change, and we've talked about this in a previous video. Your mass won't change whether you're on the Earth or the Moon. The weight will. Okay, here we go. So this is Moon, gravitational field strength on the Moon. This is the force of gravity on the Moon. And in green, we've got the gravitational field strength on the Earth. And this is G Earth. Very good. Okay, now what we're going to do is we're going to describe a couple things. So we need my mass first of all. So my mass, this should be me, but whatever. My mass is around 65 kilograms. 65 kilograms. Okay. Remember, we need the units for mass to be in kilograms. Okay. 65 kilograms. And the gravitational field strengths differ. So on the Earth, okay, and you can look this up, gravitational field strength is around 9.8 meters per second squared. Okay. Now on the Moon, the gravitational field strength is 1.6 meters per second squared. So what we can do is we can calculate our weight, okay, on the Earth and on the Moon. So Fg Earth, okay, is going to be my mass of 65 kilograms multiplied by 9.8 meters per second squared. Now the units are going to be in newtons for forces, which we've talked about. And what do we end up getting? So 65 times 9.8, 637 newtons of force. Now, what about the Moon? So let me circle this. Whoops. Let me circle this. We got, boom, Fg Earth. And now let's calculate Fg Moon. So let's do the same calculation. The same calculation, but it has the Moon's values. So if you go 65 kilograms times 1.6, 65 times 1.6, you get 104 newtons. Now, here's what I want to know. How much heavier am I going to feel on the Earth versus the Moon? Okay, here's how I'd calculate that. Let's go on to a new page. Let's full screen this back. So the two values were 637 newtons. If I divided that, let's go ahead and divide that by 104. What I'll do is I'll get the ratio of the weights. So I'll feel a certain amount times heavier on the Earth than the Moon. This will give you that amount. So divide by 104. It is 6.125 times heavier on the Earth than the Moon. Okay, so that's telling. So on the Earth, you feel 6 times more massive than you do on the Moon, even though what makes you you is the same, like everything that's inside your body is the exact same, but the fact that the Earth is so much bigger than the Moon, the gravitational field strength turns out to be bigger, and so how your mass reacts to that turns out to be 6 times more than on the smaller object known as the Moon. So that's telling. Interesting stuff. In the next video, what we're going to be talking about is Newton's second law. I'm excited for that one because we've got net force equals to the free body diagram stuff that we talked about in the previous video. So it's going to be great. I love it. And if you guys enjoyed this video, don't forget to leave a like, subscribe, comment, and I'll see you in the next one. Peace out, guys.